Okay, let's talk about proportional and non-proportional relationships. So let's say I start with a t-chart with x and y's, and if I'm looking at those values, maybe I have 0, 1, 2, and 3 on my x, and then for y's I have 0, 3, 6, and 9. This looks a lot like those in and out on the what's my rule. And so I want to determine what the rule is. Well, 0 to 0 doesn't tell me much. I could have done nothing. But 1 to 3, maybe I added 2. From 2 to 6, I did not add 2. That would be add 4. So let's come up with a new rule. What do you think this rule might be? Good, you're multiplying by 3. So we could write that as y equals 3x. This is an example of a proportional relationship. And if you bear with my typing, we know that a relationship is proportional if its equation is of the form y equals kx. Where else have we seen y equals kx? Good, we saw it with direct proportions. And of course, with this, k is not equal to 0. The graph of this passes through the origin, or 0, 0. And because I can't type is not equal to, go ahead and make sure you know that k cannot be equal to 0. So cross through that equal sign. Bam. So let's look at some examples of identifying if a relationship is proportional or not. So I'm going to actually start drawing these charts horizontally, just so it's a little bit easier to look at. So the reason I'm setting these up horizontally is like this is because you'll start to see they look right fractions. So 1 over 45, 2 over 90, and 3 over 135. And if you remember how to do ratios and proportions from last year, or before that, I'm trying to see if these are equal to each other. So what if I reduced 2 over 90? That would reduce to 1 over 45. And if I reduce this one, it would reduce to 1 over 45. Remember, I have to divide the top and bottom by the same thing. So this one I divide by 2 over 2. This one I divided by 3 over 3. So these all kind of reduce to the same thing. So yes, these are in proportion. And the formula we could write using y equals kx would be y equals, what do you think our k would be? Well, k is going to be whatever I need to use to jump from here to here, which is plus 45. Let's try another one, and I'll let you guys try this on your own. So determine if that is proportional or not. Right. 1 over 9 is not equal to 2 over 12, because if I reduce 2 over 12, that would be 1/6, and that's not equal to 1/9. And 3 over 15 is not equal to those either, because that would be 1 over 5. So this is not proportional. Just because it's not proportional does not mean we can't find a function rule for this. And you guys know that from doing the What's My Rule Center. So if I'm looking at 1 to 9, what could one of the rules be? Well, you might think it could be like x plus 8. But does that work for 2 to 12? No, because 2 plus 8 is 10. So I go back to my drawing boards and I say, okay, what if I multiply it by 2? 2 times 1 is 2 plus 7. Does that work over here? 2 times 2 is 4 plus 7 is 11. We're getting closer to 12, but we're not quite there. Okay, what if I multiply by 3? 3 times 1 is 3 plus 6 is 9. Does that work over here? Well, 3 times 2 is 6 plus 6 is 12. And we check it for that last one. 3 times 3 is 9 plus 6 is 15. So we know our function rule is 3x plus 6. Notice this is not of the form y equals kx. Okay, so that's how we also can check that it's not proportional. Let's try another one on your own. I'm sorry, x on top, then y. Tell me if that's proportional or not, and then write the function rule for this one. So you should have gotten that it is proportional, which means we automatically go to y equals kx, and my k would be 75. So I have y equals 75x. One more for giggles and grins. Tell me if it's proportional or non-proportional, and also come up with that function rule. And I will see you in class next time.